Back, and here's the solutions for example number 1, check your understanding. You'll notice that they're asking us to sketch the image after a reflection on the y-axis, which means that you multiply all the x values by -1. So stated down here, if you have a point x comma y on the original graph, it gets to become -x comma y on the image graph. So I've gone through here and for example, this point here, I'm having some trouble. This point here turned into that point. This point here turned into that point, and so on, and I connected them out. Join the corresponding points in order to form the reflection image. So the domain of the original graph was -3 is less than or equal to x, which is less than or equal to 5. So that's the original. Now the image, notice what happens. Since we're multiplying all the x values by -1, this -3 becomes 3, the 5 becomes -5, and now they get reverse order because -5 is the smallest value there and 3 is the largest. So that's why two things happen. The 3 and the 5 get multiplied by -1, and they tend to reverse the order. Because the y values don't change, the range stays the same for both of them. Alright, so let's take a look then at your example number 2. So in this example, it's really the exact same question. Sketch the graph of y is equal to f of x, f of -x. So what does that mean? That means that we're multiplying our values by -1, right? I have a different kind of a cursor here. We're multiplying the x values times -1, which means that we're reflecting over the y-axis. And so if you look at here's the y-axis, and when you look at their solution, they show both at once, don't they, right? So here's the original one, and then the reflection looks like this. Now they don't just pick a point and then draw the point. They're quite what's the right word? Methodical about this. They pick a bunch of points in the original one. So here's the x value and the y value on the original graph. And then they're saying, oh, okay, I need to multiply the x values by -1. So you see the -4 becomes a +4. The -3 becomes a +3. So they do that for each of the dots on their original function, and they're just picking convenient dots, right? You pick the y-intercepts, pick the x-intercepts, and any time where you have the two lines crossing somewhere so that you have nice whole numbers, and then you can make your second table and then graph from that. So here's a bit of a method if you're having a little bit of difficulty, or if you're just not quite sure about doing them dot by dot. I'll let you take a look at the check your understanding number 2 here. It's the same idea. Now be careful, because in the example that they gave here, they're multiplying your x values by -1, but in this format, you remember that what's happening is the y values are being multiplied by -1. And so in other words, it's reflecting over the x-axis. So here is the x-axis. So you know approximately, you can kind of sketch what that shape's going to look like, right? It's going to something, oh, I think I kind of goofed, something like that. Let me cheat by looking at the show your solutions on this one. So again, they're going to follow the same pattern. They're going to make a nice table of values. Oh, they didn't actually give you a sketch, did they? So they gave you a table of values, but they don't actually sketch it for you. But I think you can get the basic shape and the basic method there. We have one more example to get through, and then you can do your homework. So for example number 3, now it's not using a table of values, but it says write the equation of the graph of a reflection image. Same as before, there's going to be two types of reflections, right? You're going to have your y is equal to f of -x when you're multiplying the x values by -1. So that's a y-intercept or a y-axis reflection. Or the other type is you're going to have y is equal to -f of x, and that's when you're multiplying your y values by -1 or reflecting across the x-axis. The one that they chose here is reflected in the y-axis. So reflecting in the y-axis is this example here. So you'll see what they did is they took your original y is equal to the square root of x minus 3, and what this means is wherever you see an x, replace it with a -x. So that's the first line here. Now they take the original function, and wherever they saw an x, they change it to a -x, okay, and then reduce any parentheses or multiply out that negative value, however you want to do. In this example, it's fairly straightforward. So that's their solution. let's take a look at the check your understanding here. The graph was reflected in the x-axis, so it's the opposite one, right? In their example, they were reflecting across the y-axis. Now we're reflecting across the x-axis. So we want to choose this example where y is equal to negative of f of x. So in other words, looking at their answer, you don't have to put it like this that they wrote y is equal to negative g of x. What I would just do is take a look at this entire expression on the right hand side and realize, hey, I'm going to have to put a negative sign. Like, see how this looks the same as this over here. So when we put your negative sign out in front, and now just like in the other example, we're going to drop the parentheses and multiply that negative out. So the negative here multiplies by the negative 2x squared, so that's why we get a positive one here, and that's why we get a positive half. So that is your last example and your last check your understanding. Let me see here. Okay, so you should be good to go for any of the homework assignments. Let me just see if there's anything crazy. Oh, I think you should be straightforward. So I look forward to seeing how you did on that. Thanks.